Okay, guys, now we have come again at two-dimensional relative velocity. You know, in the other video, we discussed about one-dimensional relative velocity. Now we talk about two-dimensional relative velocity. So now, in order to explain it very well, we need to use maybe a question to do that. Okay, but before going to questions on that, I will just like tell you what you should do if you are asked question on this. Let's see what you will do. Now, let's say a car and a lorry, let's say they took off from the same point. Let's say the lorry travels northwards, okay, with a velocity VL. Let's say the car travels eastwards with a velocity VC. That is this velocity of the car. This is velocity of the what? Of the lorry. Now they ask you a question: what is the relative velocity of the car with respect to the lorry? Okay, that is what they mean. Is they ask you what is velocity of car with respect to lorry? That is VCL. Okay, that's the question that they ask you. Now this is a two-dimensional relative velocity. Now see the relative velocity of the car with respect to the lorry. You know what this question means? That is, with respect to lorry, how someone from the lorry will see the car. Do you understand? Someone from the lorry, will see the car. Now, look at it here. You draw a line from here to here, from this point to this point. Okay? Now, see what happens. Remember, initially, this car is moving eastwards and the lorry is moving northwards. Okay? Now, remember they ask you how someone from the lorry will see the car. That is VCL. See what you do. You see this arrow here? See this arrow? We change this arrow. This arrow will point, this one will point downwards. This one will point like this in this direction. Guys, you see this resultant? This resultant is VCL. This is the VCL we are talking about. And this is the angle. This is where you put the angle. Okay? Yes, the angular direction, theta. Do you understand? This is how it will look like. You know, when you change this direction, see, this is a vector. This is another vector. Okay? This is another vector. So, you know, if you want to add two vectors, you take the line from the tail of the first vector to the tip of the what? Last vector. That is, you know, tail to tip method. See what I mean? Tail to tip method. Do you understand? That's it. So this is clearly the VCL, the relative velocity. Okay. If you want to calculate for this theta, very, very easy. Like tan theta is equal to what? VC over what? Over VL. You know, opposite over adjacent. Very easy. So theta is the tan inverse. The tan inverse of what? VC over what? Over VL. So this is it. So this is how to calculate it. So some questions on this will lead you to scaling triangles. That is, triangles that are not right angle triangles. Yeah, it's possible. Of course, it's possible. So easy. So I will now come with questions on this, like other questions on this. Okay. So I've given you the necessary things you need.